Hi, you are welcome back. Let us continue from where we ended. Today we are going to consider angular velocity, and angular velocity is represented by the symbol omega. So this is the symbol for the omega. Now, let's consider a body moving along a curved path. So as the body moves along the curved path, there is an angle described, and the angle described there is what? Is the angle what? The angle theta. So let's say if the angle described is theta within a time frame. So let's say, let me call the time frame, or let me call the time t. So my t refers to the time, and my theta refers to what? An angular displacement. So if you have a body moving along a curved path, whereby the body describes an angle theta within a time frame t, when you take the ratio of the angular displacement and the time, you will get what we call the angular velocity. So we say angular velocity, therefore angular velocity equals, that's my omega, equals the angular displacement divided by what? Divided by the time t. So therefore my angular displacement, which is my omega, becomes what? My theta over my t. This is the expression for the angular displacement. I don't expect you to achieve this, because you know that velocity is what? Displacement over what? Over time. And now here we are just adding angular to the velocity here, and we are also adding what? Angular to the displacement, and therefore it becomes what? Angular velocity. So you can define angular displacement as, angular displacement is the rate of change of angular displacement with respect to time. So our angular displacement is the time rate of change of angular displacement. They are all the same. So angular displacement is the rate of change of angular displacement. It's correct. Or you can say angular displacement is the rate of change of angular displacement with respect to time. That is that. And someone will be asking, why don't I add the time? This is the same thing. We see in mathematics, when we talk about rates, we have a topic or a subtopic in calculus or differentiation called rates of changes. So whenever you have something called rate simply means any quantity per time. When you have any quantity and you divide it by time, that is simply rate for you. So if I'm bringing rate here, so it means I have in mind that the angular displacement is being divided by time. Please, are you okay? Or someone can also define it this way. Angular displacement is the time rate of change of angular displacement, and it is also correct. Are you okay? Now, let's deduce the unit for angular displacement. You say angular displacement is angular velocity. Let's deduce the SI unit for angular velocity, omega. And angular velocity is the angular displacement per time. And What is the SI unit for angular displacement? And it is what? Radian or rad. If you want to know more, you can go and watch the previous videos. I've explained it over there, better understanding. Are you okay? So the SI unit for the angular displacement is by radian, or simply say rad. And you know that the SI unit for time is what? Is seconds. So rad over second becomes what? Rad per second. So rad per what? Second. So the SI unit for angular velocity is radian per second, or rad per second. I hope everything is okay. Now, let's look at the relationship between radian and revolution per second over here. And in my previous videos, we talked more on the topic radian measure, where we learned the relationship connecting revolution and radian, and degrees and radian, right? And I hope you remember this relationship. 1 revolution is equal to 2 pi radian, right? Now let's look at the relationship between revolution per second and radian per second. It's very, very simple. So this one, we say 1 revolution per second is equal to 2 pi rad per second. Are you okay? You just added something small. There's just small modification over here. Just add per second here, just add per second here. So this is the relationship. Thank you. I'll end here. We shall continue next time. Bye bye.